So 2-1, looking at formulas and variables. There's sometimes, I don't tend to ask a ton of definitions on quizzes and tests, but you should know what the different things stand for. So when it asks you in a question to identify all the variables or which formula, that you kind of have in your head like what they're talking about. So, all right, if we have this first one here, so this 24-hour car race in Daytona, which would just be sweet, like 3 to 5 drivers. If a car averages 103 miles for 24 hours, how far does it go? Does anyone know the equation for distance? Go for it. Or how to find it? Or?
No, just multiply it.
Perfect, just multiply them, exactly. So the official equation is distance equals speed times time. But if it's 103 miles per hour, that's our speed. Does multiplying make sense? Because if it was 1 hour, you go 103. If it was 2 hours, you agree it's double that, 206. So 103 times 2 gives you that. So we just multiply that by 24 hours. And when you do that, 2,400 plus, anybody actually do the math? 2,472 miles.
How do they do that race? Do they just do it like, so you race until you go to the end or after?
Right. Here's where you get excited about the units, because you agree hours is the same as hours over 1. Remember learning back in the day you could cancel something in the numerator of a fraction with something in the denominator if you're multiplying the two?
What?
Yeah. Remember like fractions, if you have like 2/3 times 3/4, you could cancel the 3's out, make them both a 1. Does this look familiar?
No.
Ooh, guess what we're doing in chapter 4? Okay, so I won't get excited about it now. We'll get to do that in chapter 4. Okay, so if we were to have that, looks like I should have filled this in down below. So formula is distance equals speed times time. You could put in the different things there and come up with the answer. Fair enough? But if we were to have this formula, distance equals speed times time, sorry, I'm totally not where I'm supposed to be in my notes. We'll get rid of that. So a formula, what I meant to put there is a definition. Whenever you have a formula, it's a single variable. Equals something. So for an example, you could say distance equals speed times time is a formula because you just have a single variable is going to be that d. Fair enough? Have you guys done circumference of a circle, those equations?
Sort of.
So circumference of a circle is 2 times pi times r. It's really sloppy, r, but that would be another formula because it's just a capital C, the circumference equals. So formulas have to have a single variable equal something, yes? And what we did up here, started with our formula, then we put in a number for S, we put in a number for T. When you're playing soccer and somebody comes in for you from the sideline and replaces you, we call it substitution. Same thing for volleyball. So putting numbers in for different variables is called substitution. Because what we did is we had this formula up here at the top, and we took and we replaced S with 103 miles per hour. We replaced T with 24 hours. We substituted those numbers in, and that was able to give us an answer. Fair enough? I'll be honest with you. Trying to figure out, phrase it in a nice way. People that show their work do a lot better. I taught science for a whole bunch of years, taught math for a whole bunch of years. I'm officially old. People that show their work do way better. I'd encourage you to be someone who shows your work because you're getting like the harder math now. But area equals length times width gives the area of a rectangle with a length of L and a width of W. Find the area of a rectangle with length of 5, width of 7. So find the area of a rectangle. There. People that go through and first write A equals L times W are more likely to get it right. Because, well, what do we do with the 5?
Times by 7.
Yeah. Trying to do it in smaller steps. Length of 5, so you put a 5 in for L. A width of 7. Put a 7 in for W because we have the length and the width. Yes? So then it tells you to multiply them. There's a whole lot of people in science and math that they don't ever use the equations. They just try to memorize. Oh, you take the numbers and you do this to them if it's area. You take the numbers and do this to them if it's perimeter. Take the numbers and do this to it if it's surface. It's like, no, my friends. Math can be way, way, way easier. Science can be way easier than you make it. Just take the formula, then look at what you put in for the different variables, put those in, and then do what it tells you to do. Yes?
Yeah.
There's a lot of the stuff is really kind of easy. People just make it harder than it is. Please, my friends, do the make it easy. All right, can we do the backside?
Yeah.
Rounding. I'm going to start nickel and diming you on quizzes and tests, starting in chapter 2 for rounding. Just get used to the habit you always round. Anytime you're not writing all the decimal points, you always round. Every time. So if the next digit is 5 or higher, then you round. Nice. Round up. So 5 and above, give it a shove. I've heard that before. 4 and below, keep it low. So then you round. Oh, let it go. Say let it go. Into that. Round up, give it a shove if you learn it that. Either way. So next we need to get place names so we know what we can round to. And we want to start out by pointing out our decimal point. So we have our decimal point right here. And going to start, and we'll do these here. So this one right here is the 1 spot. And then 2 is going to be the tens. 3 is the hundreds. And now we get into kind of a group of 3. 4, 5, and 6, those are all in the thousands. So 4 is just going to be the thousands. Then we kind of repeat these two. You know, kind of like you have a group of 3 here and so on. Kind of repeats a couple of those. So we have thousands, kind of like the ones. And then we have 10,000s is my 5. So 10 thousands. And 6 is kind of like my 3 right there, is like my hundreds, is 100,000s. Then we have a comma. And now the next 3 kind of repeat what 4, 5, and 6 did, but instead of thousands, it's going to be millions for each of those. So 7 is kind of like my 4, it's just going to be the name millions. 8 now, the second digit in that group of 3 is the 10 millions. And 9, the third one, is going to be the 100 millions. Then if we were to keep going, you'd have another comma, and then you'd have billions, 10 billions, 100 billions, comma, and trillions, and so on. Just keeps going. Now on the other side of the decimal point, I'm going to go in the red, just to show that it's different. I was always confused because it repeats these numbers over on this side, but it starts with the tens. That it starts out as tenths. So instead of just the S on the end, we have add in a THS. So whenever you're to the right of the decimal point, you're going to have a TH in there. So tenths, and then hundredths. So THS. And then thousandths. So you'll notice these to the right of the decimal, they all have that TH in there before the S. And then you could have a comma, and then it'd be 10 thousandths, 100 thousandths, millionths, comma, and so on. With those, I was always kind of confused, but I'd look at it this way. If you have 0.1, if you haven't learned it already, you'll learn that you could write that as a fraction by saying 1 over 10. So in this case, 0.1 is the same as 1/10. Or if we had, say, these 2 digits right here, you should include the decimal point. But if you had 0.12, that's going to be 12 over 100 before you reduce it. So that is 12 hundredths. So even though we only have like 2 decimal points where it seems maybe like you should be, you know, like this spot, It's hundredths because it's 12 hundredths once you write it as a fraction. And same for this. It'd be 123 over 1,000. So it's 123 thousandths and so on. Okay, very last thing today, we take and combine those two things together. The rounding stuff with these different place names. So to do that, I'm going to look at each of these and say, all right, so first I want to round to the thousands place. So that's a DS. So we're talking to the right or left of the decimal. So I have ones, tens, hundreds, thousands. So we're looking at that 32. So we want to round to this point. Whenever you're looking at rounding, you look at the digit that's after it. So because that's a 4, we round down. We just make this 32,000. We don't round the 2 up to a 3. But you have to put the zeros in so it doesn't just become 32, it becomes 32,000. Because this original number here is way closer to 32,000 than it is to just 32. All right, the hundred thousands place. First, we need to figure out which one is the hundred thousands. So we have thousands would be my 2, 10,000s is my 6, 100,000s is right there with the 3. So the numbers before that, we always just write those in. So 457 million, comma. Now you have to decide, do we round the 3 up to a 4 or do we keep it a 3? And for that, you only look at the one number that's after it. So that's a 6. Because it's a 5 or higher, we need to give it a shove up. So the 3 becomes a 4. And then you have to put in the zeros to keep it in the right place. So you still have 457,400,000. Okay, now we're switching a little bit. And in class, usually, my kids aren't here right now, but usually I'll ask them, like, what number am I rounding to? And a lot of people will say the 7, but because we have this TH in there, we're rounding to that 3 right there. So you can write all the numbers before it. Those will just automatically get copied in. So I have 45,271 point. Just need to decide, do we keep it a 3 or do we round it up to a 4? And again, you only look at the one digit that's after it. Because that's an 8, that means we have to round the 3 up to a 4. Now here, we don't put in zeros. That'll tie into significant figures you'll learn later on in life. We just leave it as a 0.4 in that. In this first one, the blue one up above it, we had to have the zeros to keep it the decimal point in the right place. We don't need that now that we're after the decimal point. Okay, hundredths place. So TH again. So we have tenths right there for my 3. Hundredths would be the 8. So I can write all the numbers in front of it, 45,271.3. And now, to figure out the 8, do we leave it at 8 or round it to a 9? You look at the next digit. Next digit's a 1. So it fits that 4 below, so we just keep that as an 8. A lot of people don't realize that's rounding down, but technically, this number here is 0.001 less, and we lopped off that last number. Very last part, we have round to the hundreds place. And hundreds, because we don't have the TH, it's just the DS. And then we have our ones, our tens, our hundreds. We're rounding to right there. So 45,000. Then do we leave it a 2, make it a 3? Because our next digit's a 7. It's a 5 or higher, so we round that up to a 3. And then we need to have the zeros to hold in the place value. Usually don't write in the decimal point though, but 45,300. 45,300. That's it for this section. Let me know if you have questions.